Hey everyone, welcome back to my channel. Today we are building something absolutely sick from scratch. A fully functional AI chatbot that answers questions about Stripe's entire documentation. We are talking pay intents, webhooks, subscriptions, the whole thing answered intelligently. So let's check the an example. Uh, and we are building this using vibe coding, meaning I am going to be writing prompts, not code. Every single file in this project gets generated by an AI. Before we prompt anything, we need a skeleton. One thing I'll have learned from vibe coding complex projects, you cannot just dump a massive prompt into an AI and expect magic. You need structure first. Here is the architecture we are building. Think of it as an assembly line. Stripe docs go in one end, user question gets answer at the other end. So there are many steps. I would just be repeating the steps. So step 1 is scrape, step 2 clean, step 3 chunk, step 4 embedded into vectors, step 5 store in FAISS, step 6 retrieve, step 7 re-rank, step 8 build a smart prompt, step 9 send to GROQ, step 10 serve via FastAPI, and step 11 display in Next.js. Every step has test. That is non-negotiable when vibe coding. If you do not test each step, you will hit a bug in step 9 that was actually caused in step 3 and you will waste hours. Trust me. Let me create the project structure now. Alright, phase 1 of actual build. And this is where the vibe coding begins. We need to scrape Stripe's documentation, not just grab random HTML. We want structured, clean data, title, URL, category, headings, content, and code examples. Here is the exact prompt I am going to paste into Antigravity. So this is the prompt. I am just copying it. I'm just pasting it. And send. This is the website from which we would be crawling each and everything. From prompt 1, we can see that there is an implementation plan been created for Scraper, and this is the implementation plan. Okay, now I would be doing proceed. So the scrapping has been done successfully after executing the prompt 1. So this is the scrapping part, scrap data. Okay, I have scrapped around 233 pages, I would say. And after scrapping, I have used prompt 2. Like, we also need to clean the scrap data very well. Okay, so yes, this is the prompt, and the data is also been cleaned. So the clean data file is here. Okay, so yes, there might be some duplicates. That's why it's 228, but there it was 233. And the next step is chunking. Chunking is honestly one of the most underrated steps in RAG. Get it wrong and your retrieval will be garbage regardless of how good your embedding model is. So I will be copying this prompt and I will be putting it here. Okay, send. After the chunking part is done, Now we are converting text into numbers. This is where the magic happens. We are turning words into vectors that capture meaning. Two sentences that mean the same thing will have similar vectors, even if they use completely different words. For this thing, we are using BG small. It is only 33 megabytes, okay, and runs on CPU. And it is legitimately one of the best small embedding models on the planet. So this is the prompt I will be pasting, and I have mentioned about the BG small. Okay, so I will be pasting this prompt here. I will be using Gemini Pro model. Send. So now we are done with embedding part. Okay. Now we will be coming at the phase 5 prompt. So FAISS is our search engine for vectors built by Facebook AI Research. It's totally free and it's insanely fast. For under 10,000 vectors, it searches in microseconds. So I would be copying this prompt and pasting it here. Okay, enter. We are done with FAISS vector store, and the next prompt is for retrieval function. So this is the bridge. User types a question, we embed it. We search FAISS, we get back the most relevant Stripe doc chunks. Simple in concept, but the devil is in the details. One key thing, BGE models use different prefixes for queries versus documents. For documents, we embed raw. For queries, we add represent this sentence for searching relevant passages. This significantly improves retrieval accuracy. So I'm just going to copy this prompt and paste it here. Okay, build a retriever, and I'm just going to send. So here retriever module is done. Okay, as we can see here. And the next prompt is for reranker. So here is the trick that most RAG tutorials skip, and it makes a huge difference in answer quality. FAISS retrieval is fast, but it is comparing vectors independently. It does not look at the query and the chunk together. A cross encoder reranker does exactly that. It looks at the pair and says, given this question, is this chunk actually relevant? Way more accurate? We fetch 10 from FAISS, re-rank to 3. The 3 that survive are the ones we send to the LLM. Less noise and better answer. So yes, I'm just copying this prompt and I'm just pasting it here. Okay, this is re-ranker, build a re-ranker. Okay, execute. So now we are also done with the re-ranker part, and we have also executed the test cases and it's passed. And now we will be checking out the prompt for the prompt builder. So everything up to now has been about finding the right information. Now we need to tell the LLM how to use that. So prompt engineering for RAG is both an art and a science. We need to inject the retrieved context clearly, tell the model to only use what is in the context, ask it to cite sources, and request a structured JSON response. So yes, I will be copying this prompt. Okay, for prompt builder, I have just pasted it here. Okay. And yes, it's been generating. So now we are done with the prompt builder. The next prompt would be for GROQ LLM. Okay, everyone, pay close attention here. This is the most important phase in the entire video. Not because the code is complicated, because of how we test it. So GROQ is an external API. That means our test cannot just call it. We need our unit test to run without any API key. And we need our integration test to run with one. Clearly separated, no ambiguity. If you get this wrong, your CI/CD breaks every time someone does not have the API key set. Get it right and you have a bulletproof pipeline. Also, before you use GROQ, go to console.groq.com and we can get our API key created here. So API keys, okay, this is the website, and just click on create API key, and I'm just typing Stripe API. Okay, I'm just setting expiration date, submit. Okay, I'm just copying this API key, and I would be just pasting the API key here. Okay, okay, this is pasted, and I would be pasting the prompt as well. Pasted. Okay, now the GROQ API part is been implemented. Okay, let's check whether this gets passed or no. Okay, one got failed. Okay, because there is no API key. That was the only reason it got failed. Okay, there might be a test case which is linked to API key. Now let's see after adding the API key what happens. Okay, in .ame file, I'm just pasting it here. Ctrl S. I'm just running the same command. Oh, it's getting failed again. Okay, the model llama has been decommissioned and is no longer. Please, okay, refer to this. Okay, I will be just be giving this issue error. To anti-gravity. I think this issue has been resolved because initially I had given to use llama 3 8b 8192, but it was decommissioned. So yes, anti-gravity made the changes which are required. Now let's try to run this thing again. It runs or no? Okay, 9 passed. Nice. Okay, and let's see here as well. Refresh. 3 API calls. Okay, that's nice. So now we go to the next prompt. It is FastAPI backend. Okay, now we wire everything together. The FastAPI backend is our orchestrator. It receives a question, runs the entire pipeline, and returns structured response. So I have just copied the prompt. I'm just pasting it here. So finally, we are done with the API thing, and we have also tested this thing, the fast API. And the next prompt is for front end. So it's front end time. We are building a chat interface that feels like talking to a genuinely smart Stripe expert. So this is just a basic prompt. Let's try and look how it looks. The front end part is been done, and now let's check how it looks. Yeah, I'll just check the APIs. Okay, 4 APIs are used. Okay, maybe I will just click how to handle. Okay, fail to fetch. Yeah, I'll just try to write a question. Fail to fetch. Okay. Okay, it seems like it was my fault. The failed fetch error you were saying because the fast API backend was not running when you tried testing. When it tried to run source, okay, locally we were inside the frontend folder, so it couldn't find the virtual environment. Okay, okay. You can freely go back to the browser and perform your end-to-end manual testing. Okay, let's see. This is the browser. I'm just reloading it. Okay, now I'm clicking it on this thing. Wow, nice. To create a payment, you can use the Stripe API. Okay, oh, I'm getting something with some link. Okay, payment intents, sources also I'm getting. Payment is cancelled. Okay, if a payment is it is transient. Oh, nice. The thing is, the data which I have scrapped is a bit limited. Like I have scrapped around, I would say, 230 pages, but there are more than thousands of pages. And yes, so we have completed till here the front end part, and the front end part is working fine. And there are few prompts as well in detail. So if you are interested, you can just take the screenshot of this prompt and try doing it for yourself.